चलो हम डिस्कस करते हैं जो प्रीवियस क्लास में हम डिस्कस कर रहे थे। मॉड्यूल 4 मैकेनिकल मेजरमेंट। ओके। और प्रीवियस क्लास में हम टेम्परेचर कैसे मेजर किया जाता है, कौन सा जो डिवाइस होता है मेजर करने के लिए टेम्परेचर, और उसका वर्किंग प्रिंसिपल अब डिस्कस किए थे। ठीक है, तो हम फिर इसको थोड़ा रिवाइज कर लेते हैं उसको। आप सब ठीक से याद रखो। हम्म दिख रहा है, देखो। दिख रहा है तो
यस सर।
ठीक है। हम जो बोल रहे हैं आप सब सुनो। पिछले क्लास में हम मॉड्यूल 4 स्टार्ट कर लिए हैं। अब अगर फिजिकल क्लास आओगे तो फिर वो चीज जहाँ तक पढ़ाई होगा उसके आगे पढ़ाई होगा, और क्लास में रिवीजन होगा। तो तैयार करके सब आओ। अब जब आ रहे हो सब स्टीम टेबल खरीद के लेके आना। ठीक है, स्टीम टेबल और कैलकुलेटर जिसके पास नहीं होगा, फिजिकल क्लास स्टार्ट होने में वो क्लास को अलाउ नहीं किया जाएगा। आप आओगे तो हम सिर्फ न्यूमेरिकल डिस्कस करेंगे और जो प्रॉपर्टीज ऑफ प्योर सब्सटेंस का क्वेश्चन आंसर करेंगे। समझे रे?
यस सर।
यस सर।
सभी आपका जो स्टीम टेबल, इंजीनियरिंग कैलकुलेटर मस्ट है। यू कम विद दैट वन। Okay, so in the previous class we have started module 4 related to mechanical measurement. Okay, and here we will discuss working principle of some of the measuring instrument used for measuring temperature, pressure, flow, strain, like that. Okay, so as discussed, temperature is a temperature, point. Then we found thermocouple to find. So thermocouple works on the principle that when two conductors made from dissimilar metals, सब सुनो ठीक से। Thermocouple works on the principle that when two conductors made from dissimilar metals are connected, forming two common junctions, and the two junctions are exposed to two different temperature, a net thermal EMF is produced. Okay. So the thermoelectric EMF generated is due to the combination of two effects, that is called your Peltier effect and Thomson's effect. That means your thermocouple works on the principle of Peltier and Thomson's effect. As the temperature goes up, the output EMF of thermocouple rises.
सर साउंड नहीं आ रहा है।
हाँ रे, वो नेटवर्क पुअर कनेक्शन के चलते वो डिस्कनेक्ट हो गया था, फिर से अभी रिकनेक्ट हो गया है। आप लोग सब सुन पा रहे हो?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So you yesterday we discussed temperature measurement and few devices we found that it is used to measure temperature, and one of it that liquid in glass thermometer that was discussed in details. Thermocouple you already also heard, otherwise you can also search how it looks like in your once you come I will show you. And thermocouple, if you can see here, let's move to the other slide. This was liquid in glass thermometer, which was discussed in the very last class. Okay. And what is the advantage of using alcohol, and what is the advantage of using mercury in that liquid in glass thermometer as a thermometric substance? Okay. So there is some potential toxic hazardness of mercury, so we replace with alcohol, but that alcohol also possess very what is that, it can weight the glass tube, and also it is used to measure low temperature. Okay, then we started bimetallic temperature measuring device, which is a bimetallic from its name. It is clear that it uses two different materials, okay, having different rates of thermal expansion. That means this you can remember that bimetallic temperature measuring device work on the principle that different materials have different rates of thermal expansion. When two strips of metals are bonded together and gets heated, one side will expand and other side will, that means one side will expand more in comparison to other, and the resulting bending is translated into temperature reading by a mechanical linkage. Okay, because of that bimetallic strip, okay, also having different thermal expansion property, so it bends, one end bends more than other. This bending, okay, this bending can be converted into temperature reading by some mechanical linkage. That is the working principle of bimetallic thermometer. You can see how it works. Here the bimetallic strip is bonded together, okay. The metals are joined together at one end with help of welding, okay. And then since bimetallic strip thermometer is constructed with two different metal, so the length of the metal changes at different rates. So this is the working principle of a bimetallic thermometer. Here that a bend of that plate or that strip helps to record the temperature, hence its name is bimetallic temperature or thermometer. You have to remember this is another device after liquid in glass thermometer is also used to measure your temperature, temperature of the body or system. Then you can see here how that strip of the plate gets bent, okay, when there is one end heated, and you can see here this deflection can be converted into reading of temperature, okay, through a mechanical linkage. You can see this is the bimetallic strip, and after that heating process, how one end that is called free end, which is starts to bend, whereas that fixed end remains like that. How that bending takes place. This is called your deflection, which to measure temperature. This bimetallic temperature device. How that bending, are you all able to identify it or not? कैसा डिफ्लेक्शन
Yes,
हो
yes,
रहा है,
sir.
देख रहे हो तो? हाँ. So that means when one end gets heated, other end your one end expanded more than other, how it is graduated to that temperature recording value, okay, or through that mechanical linkage a pointer is attached. This pointer position determine. This expression is not required for you because you have to only remember the working principle of measuring device. So that diagram along with a working principle you have to remember and write. Suppose you are thinking that how this thermometer, spiral strip bimetallic thermometer works. You can see here in a bimetallic strip thermometer when the spiral shaped strip is used, it is measuring ambient temperature because the thermal expansion of the property of the metal deform occurs in the spring with the variation of temperature. Here the pointer is all. Once this end is heated, this will expand, and that free end moves and it is also graduated to some value and corresponding to the pointer position, the temperature is recorded. So here another is industrial type bimetallic thermometer. You can see how it is helps to measure the temperature. It is another type bimetallic strip. It is helix type. The earlier one was spiral type. It is helix type. So helix type bimetallic strip is mostly used in industrial application. Here a helix shaped strip is used for measuring temperature. The free end of the strip is connected to the pointer. The deflection of the strip shows the variation of the temperature. A thermometer is simple in construction, robust and less expensive. Which one? This helix type industrial bimetallic thermometer. Okay. The thermometer gives the less accurate result while measuring the low temperature. That means this type of thermometer is utilized to measure high temperature. For low temperature, it will not show that much accurate value. Okay. And where it is used? It is used to like in a oven, air conditioner, your industrial apparatus like refinery, hot wares, heater, temperature tanks, okay, for measuring temperature. Another one is the vapor pressure thermometer. This is not required. The gas field, it is constant volume gas thermometer, constant pressure gas thermometer. Okay. One is the thermometric property, another is thermometric substance. So thermometric substance is that one which changes with respect to temperature, and thermometric property is that value which changes. That means suppose that length of that liquid column changes, volume of the liquid column changes, pressure of the liquid changes, or pressure of the thermometric substance changes. These are called your thermometric property, based on which we are able to measure the temperature. So constant volume gas thermometer, constant pressure gas thermometer is also used to measure your temperature. So these are called your vapor pressure thermometer. Okay. Electric EMF, how that is generated in thermocouple. Okay. Here thermocouple, you can see that I discussed at the beginning. Okay. This is the diagram. It is also used to measure temperature. So when two conductors made from dissimilar metals, let A and B are two different conductors made of two different dissimilar material, dissimilar metals are connected. When A and B are connected, these are two conductors of dissimilar metal. When connected, forming a junction. Okay. So what happens there? You can see there is a EMF is generated. Okay. And this EMF is generated due to two facts or combination of two facts. That is your Peltier effect, another one is Thomson effect. So as the temperature goes up, so your thermocouple EMF for the thermocouple rises. So this is the principle on which your thermocouple works. An EMF is generated when junction of two dissimilar metals are kept at a different temperature. The combination of two metals is called your thermocouple. So a device which converts one form of energy into another is called your transducer, and a thermocouple is a transducer which converts thermal energy into electrical energy. Here you can see that because of two effects, your thermocouple works. One is Seebeck effect. The magnitude of the EMF depends on difference in temperature between two junctions. This is called your Seebeck effect. So D E subscript S is equal to alpha AB dt. So you can see that EMF produced capital E. Okay, S stands for that EMF produced due to Seebeck effect is equal to alpha AB. Alpha AB is the Seebeck coefficient, and dt is the temperature difference. So you can see from this expression that your magnitude of EMF depends on the difference in temperature between two junctions. Okay, so based on this effect, your thermocouple works. Remember this first one is liquid in glass thermometer, second one is the constant pressure gas thermometer, constant volume gas thermometer. Okay, then we discuss bimetallic temperature measuring device or bimetallic thermometer. Then we are discussing thermocouple. So bimetallic temperature measuring device works on the principle that when two different metals have different rates of thermal expansion, so because of the resulting bending, your temperature readed by a mechanical linkage. So that was the principle. You remember, I repeatedly told you that this is the principle you have to remember along with the diagram, and then we can write it. Then we are discussing this thermocouple. Here it is over also. Material used for here after two conducting material could be used here. Any two conducting material as discussed can be used for thermocouple. So, but certain materials are found to be better than others. So, material combination may be copper, constant, chromel, alumel, आयरन constant. ये सब आपका कॉम्बिनेशन है इसलिए और थर्मोकपल में जो टू डिफरेंट मटेरियल्स यूज होता है ये उसका कॉम्बिनेशन है. सो आप अगर कॉपर कंस्टेंट का लोगे कॉम्बिनेशन तो आपका टेम्परेचर वो मेजर कर सकता है -200 से 350 तक. आप सब देख पा रहे हो या नहीं?
Yes, sir.
Yes,
अगर
sir.
क्रोमेल एलुमेल का लोगे आप कंडक्टिंग मटेरियल in thermocouple it will able to measure -200 to 1300 degree centigrade. You mark here this range 1300 डिग्री सेंटीग्रेड तक वो थोड़ा मेजर कर सकता है और -150 से 1000 डिग्री सेंटीग्रेड तक ही उसका आप मेजर कर सकते हो if the thermocouple made up of iron and constant. So this is all about thermocouple. We discussed three temperature measuring device. One is the liquid in glass thermometer, second is the bimetallic thermocouple, thermometer, then thermocouple. Previous classes some that are pyrometer. Okay, there are two distinct instruments under this category. One is total radiation pyrometer, another is optical pyrometer. Pyrometry, so that means pyrometers are basically used to measure high temperature, very high temperature you can call. Now this is the diagram here. Okay. Basically, it measures the temperature by thermal radiation emitted by the material. So here you can see here this pyrometer consists of an optical system including a lens, mirror, and adjustable eyepiece. You can see lens, mirror, adjustable eyepiece. Okay, and a detector circuit. And a detector circuit is there. So an optical system collects the visible and infrared energy from an object and focuses it on the detector. ये वाला आपका जो ये हॉट ऑब्जेक्ट है, यहाँ से जो आपका टेम्परेचर जो एमिट होगा रेडिएशन, ये लेंस और मिरर के थ्रू जाके ये इधर कलेक्ट होगा और इसी से जो टेम्परेचर होगा ये वैल्यू मिरर के थ्रू ये डिस्प्लेस होगा. सो हीट एनर्जी emitted from the hot body is allowed passed on the lens which collect it and focused on to the detector with a mirror and eyepiece arrangement. So now the detector here you can see in this diagram converts the radiation energy into an electrical signal. Okay. So now that is displayed in form of pure temperature. So this is the working and construction of a radiation pyrometer. Advantage is the low cost, no need of contact. This is non-contact type, fast response. ये वाला response थोड़ा ज़्यादा speed से देता है, यानी faster response you can call. Disadvantage is emissivity errors are introduced. Here pyrometer working principle is that when temperature being measured is very high and physical contact with the medium to be measured is impossible or impractical, pyrometer based on principle of thermal radiations are used. So you always remember pyrometer works on the principle of thermal radiation. And from the definition it is clear that it is used to measure high temperature. Okay. So these pyrometer working principle are used under condition where corrosive vapors or liquids should destroy thermocouples, resistance, thermometer, and thermistor. Okay, if made to come in contact with the measured medium. So now here it is continued. You can see radiation pyrometer measures radiation energy emitted, okay, or reflected by a hot object. You can see how it is get concentrated through that lens, okay. That a black body detector, that a temperature detector we can call, that supply it in forms of electric signal which will get displaced in form of temperature. So here you can see the heat received by the detector. Okay, detector you can see from hot body it is get reflected through lens and there temperature detector. The amount of heat received by the detector is proportional to the fourth power of temperature. Okay. And here you can see this is 10 to the power minus 5 stands for Stefan Boltzmann constant. Okay. So T to the power 4 watt per meter square. So therefore heat received by the detector is proportional to the fourth power of the absolute temperature of the body. Radiation pyrometers are two types: total radiation pyrometer and infrared pyrometer. Previous class, some of you told me that sir, infrared pyrometer is also used to measure the temperature. I already now able to find how it is measuring temperature, working on the principle of thermal radiation. These are the ये वाला जो हम अभी डिस्कस किए हैं, ड्यू टू फोर्थ पावर लॉ, और that means your total radiation is very proportional to the fourth power of absolute temperature. Okay. So total radiation pyrometer cannot be used for measuring temperature lower than 600 degrees centigrade. You can see that some of the devices are not able to measure temperature up to 600 degrees centigrade, but a total radiation pyrometer starts its reading from beyond 600 degrees centigrade. Total radiation pyrometers are mostly used to a temperature range of 1200 to more than 33,000. Basically, this is the blast furnace. Furnace temperature is around 1500, 1700. There it is also. Output from total radiation pyrometer, whether amplified or not, is usually taken in PMM's instrument or to a self-balancing potentiometer. Infrared parameter are partial or selective radiation parameter, and it measures temperature above 550 degrees centigrade. It is using infrared principle using your thermocouples, thermocouple, and bolometers are used. Also, various types of photoelectric transducer are most commonly used for infrared transducer. This one is optical pyrometer, disappearing filament type. Here, the principle of temperature measurement by brightness comparison is used in optical pyrometer. A color variation with growth in temperature is taken as temperature. This is the construction of optical pyrometer. Temperature source is there, like that eyepiece, okay, red filter, you can see, absorption screen, okay, through which that filter you can see from this diagram. Here one red filter is marked, okay. It is also placed between eyepiece and the lamp to allow only narrow band of wavelength of around 0.6 MUI. So this is the operation of pyrometer as discussed and also as explained. This is the image of temperature source. Now come to the application. Application optical pyrometers are used to measure temperature of molten metals or heated materials. That means in industry you can find its uses. Optical pyrometers are used to measure temperature of furnace and hot bodies, as already told you earlier. And the advantage is that physical contact of the can plot degree centigrade. If it can able to measure that or beyond 11, so -5, you can think that how accurately to measure the temperature. An instrument is easy to operate, provide a proper sized image of the temperature source is obtained in the instrument. And what is that limitation? Temperature more than 700 or around 600 can only be measured, since illumination of the temperature source is must for measurement. That means it can measure only above 600. Sometimes you find 550, here it is mentioned 700. Since it is manually operated, it cannot be used for the continuous monitoring and controlling purpose. This is the major disadvantage of optical pyrometer. As it is manually operated, we cannot use it for continuous monitoring and controlling purpose. This is all about the types of temperature measuring devices used to measure temperature. So starts with that first one, liquid in glass thermometer. Second one, bimetallic temperature measuring device or bimetallic thermometer. Third one was thermocouple. Fourth one was your pyrometer. Okay. So all these are the temperature measuring devices. So next we will discuss pressure measurement. So now we have to identify some devices which are used to measure pressure. Sorry. This is better. As you know, pressure equal to rho G H, P equal to rho G H with the height of the liquid column. You can see. Just wait. You can see density. What is density? What is specific weight? What is specific gravity? Already discussed in your effect, one of the fluid properties. Okay, so here you can see these are the things you have to remember. Before we start that the fluid pressure and pressure measurement, density of water is taken as density, weight density, specific gravity, or it is also called as relative density. Now we start with your pressure and pressure measurement. So what is fluid pressure? We can tell fluid pressure. Slide is visible.
Yes, sir.
Fluid pressure is defined as a normal force by a fluid per unit area, as already Pascal. Pascal is same as pressure is a bar, 1 bar is equal to, it is wrongly written as 105, it is a typing error is there. So you read it as a 10 to the power 5 Newton per meter square. Am I correct?
Yes, sir.
Yes or no? 1 bar equal to 10 to the power 5 Pascal or 10 to the 5 Newton per meter square. So now what is pressure head? Pressure exerted by a liquid column can also be expressed as the height of the equivalent liquid column called as a pressure head. So if you pressure in that expression P equal to rho GH, that height is equal to H equal to pressure head, that can be calculated by P by rho G. You can see. And though we are discussing pressure, so we have to remember what is Pascal's law. May come as a 2-mark question in your semester examination, and always be prepared for your offline, your absolute vacuum gauge pressure. ये डायग्राम सब याद रखे हो या नहीं रे, जो हम निकाले थे एब्सोल्यूट प्रेशर एट एनी पॉइंट एक्सप्रेशन? अरे याद है या नहीं सब? तेजा सिंह,
Yes, sir.
हाँ भूल गए हो क्या, याद रखे हो?
Yes, sir. याद है.
Suppose if you want to find pressure at A, you can see that point A is lie above absolute zero pressure. So pressure corresponding to point A is called as your absolute zero pressure. You can see point A is also lie above that atmospheric pressure line. So from absolute zero pressure to atmospheric pressure, that is considered as your atmospheric pressure. And just point A is lies above atmospheric pressure line, hence it is pressure corresponding to this one is called your above atmospheric pressure. If it is measured, it is called your gauge pressure. Okay, so you can see pressure at A is equal to P atmosphere plus P gauge. Gauge is your positive gauge pressure here, negative gauge is called your vacuum. Okay, so defined as absolute pressure is defined as a pressure which measured with reference negative, since there is no pressure less than absolute zero pressure. ये सब आपको याद रखना है. तो गैस प्रेशर क्या होता है? जो प्रेशर मेजर होता है एटमॉस्फेरिक प्रेशर को रेफरेंस लेके. इधर देखो एटमॉस्फेरिक प्रेशर लाइन इधर है, उसके ऊपर पॉजिटिव हो सकता है, नीचे आएगा तो नेगेटिव.
Yes, sir.
Yes, sir. Yes, sir.
तेजास सिंह, तुम जो टेम्परेचर हम मेजर किए 4 डिवाइस का नाम बताओ.
Thermocoupling,
थर्मोकपलिंग नहीं होता है, थर्मोकपल.
thermocouple, thermometer,
थर्मोमीटर, लिक्विड इन ग्लास थर्मोमीटर.
thermometer,
हाँ,
हाइड्रोलिक थर्मोमीटर।
क्या क्या? बाईमेटालिक।
यस सर, बाईमेटालिक।
हाँ, बाईमेटालिक। और एक तो
और एक रुको सर,
रुको क्या, तुम अभी सुन रहे थे, पायरोमीटर।
स्पायरोमीटर। यस सर।
हाँ, सबको याद रहा तो जो 4 टेम्परेचर मेजरिंग इंस्ट्रूमेंट हम डिस्कस किए, आपको उसमें डायग्राम याद रखना है। उस डायग्राम के सभी पार्ट्स जो है उसको याद के साथ उसका वर्किंग प्रिंसिपल याद रखना है। कुछ इस आप लोगों को याद, क्योंकि यहाँ तक ये आपका सिलेबस में है, टेम्परेचर मेजरिंग इंस्ट्रूमेंट विथ इट्स वर्किंग प्रिंसिपल। समझे?
यस
अरे
सर।
समझे या
यस
नहीं?
सर।
अगले क्लास को हम पढ़ेंगे
यस
आपका
सर।
प्रेशर मेजरिंग इंस्ट्रूमेंट। चलो अटेंडेंस दो। ये शुभ्रांशु कौन चला गया रे? हाँ, रिस्पॉन्ड करो सब, सीरियसली बोलना, ठीक? हाँ, रिस्पॉन्ड करो। मंडल मंडल है रे, सुब्रत मंडल, सुप्रभात मंडल नहीं है। तो है, हसन राजा है, अरुण सोरेन है,
सर।
अरुण सोरेन है। बाकी बोलो, सीरियल नंबर बोलो जो प्रेजेंट हो।
सर
1
1
1 हो गया है। नेक्स्ट वो
3
3 9
11 12
11 12
19
7 19
23 25
23
24
25
24 सर
24 24 28
29
29 हाँ, रिस्पॉन्ड करो। मंडल मंडल है रे, सुब्रत मंडल, सुप्रभात मंडल नहीं है। तो है, हसन राजा है, अरुण सोरेन है,
सर
अरुण सोरेन